The next topic is event handling. Changing the state of an object is known as a event. And for example, click on button, drag the mouse, etc. The java.awt.event package, which provides many event classes and listener interfaces for event handling. An event is a signal to the program that something has happened. Each event must return a boolean values, that means true and false, indicating whether the event should be made available to other event handler. Here the event is an object that describe a state change in sources. It can be generated as a consequences of user interacting with the elements in GUI, graphical user interface. Any object capable of raising an event in the event sources. Event handlers are procedurals that are called as when the corresponding event occurs. Then event handling is the mechanism that controls events and decides what should happen if an event occurs. These mechanisms have the code which is known as the event handler, and that is executed when the events occur. When the events can be broadly classified into the two categories, foreground event and background event. Those events which require the direct interaction to the user, they are generated as the consequences of the personal interacting with the graphical components. And background events, those events that requires the interactions of the end users, are known as the background events. Then operating system interrupt, hardware and software failure, timer expire, then operations completions are the example of the background event. Here the event handling code performs some task and response to the event is called as the event handler. Event handling is the process of responding to the event, and that can occur at any time during the execution of the programs. Here the first is the delegation event model. For this delegations model contains any program that uses the GUI, such as the Java applications written for the Windows, is event driven. A program contains method that handle the event, such as the program is called as the event driven program. This is the diagram for event delegations event model. User actions, then operating system OS, Java library classes, and these are the events method. These are included in the programs. The modern approach to handle event is based on the delegation event model, which defines the standard and consistent mechanism to generate and process event. Its concept is quite simple, like the source generate an event and send into the one or more listeners. In this scheme, the listener simply wait until it receives an event. Once the receiver and the listener process are event and then returns. This diagram shows the delegation event model. In this model, a GUI component such as button, then menu item, etc., called a source, and which generates an event. These events is passed to one or more listener, and a listener is an object that listen for the particular event. It having some following key participant. First one is the event. Event is an object that describe state of change in the source, and events may be generated as a consequence of user interacting with GUI element, like pressing a button, moving mouse, etc. The second is the event sources. Sources is an object that generate an event, and in the delegation event model, sources generate an event and send it to one or more listeners. Then third is the listener interface. It is an interface which contains methods that the listener must implement, and the sources of the event invoke when the event occurs. Then event sources and listener. The delegations event model basically has the two main part, that means first is sources and second is listeners. Sources are the user interfaces components that generate the event. Such sources are windows, button, checkbox, text box, choice, list, menu item, scroll bar, applet, etc. In the program, listeners are created by implementing listener interface defined in the package java.awt.event. Here the event sources, first is event sources, An event sources is the object that generate an event, and this occurs when the internal state of an object changes in some ways. Sources may generate more than one type of event. Sources may register listeners in order for the listener to receive the notification about a specific type of event. Each type of event has its own registration method. Here the in addition, GUI elements, other components such as applet can generate the event. For example, you receive key and mouse event from an applet. Then following are the some event sources. First one is the button. These buttons generate action event when the button is pressed. Then checkbox generate item event when the checkbox is selected or deselected. Then third is a list generate action event when an item is double click, and generate item event when an list is selected or deselected. Then fourth is choice generate item event when the choice is changed. Then menu item generate action event when a menu item is selected. Then generate item event when a checkable menu items is selected or deselected. Then scroll bar generate adjustment event when the scroll bar is manipulated. Then text component generate text event when the user enters a character. And last one is the window generate window event when a window is activated, closed, deactivated, then iconified, open or quiet, etc. These are the event sources. Then event class and listener interfaces. These are the event classes. Action event which is the listen interface is action listener. Then mouse event mouse listener and mouse motion listener. Then key event key listener, key item item event and item listener. This is the interface. Then text event class having text listener interface. Then adjustment event having adjustment listener interface. Windows event having windows listener interface. Component event having component listener interface, and container event having container listener interface. And last one is the focus event having focus listener. Then next topic is adapter. Adapter patterns is frequently used in the modern Java framework. It comes into the place when you want to use the existing class and its interfaces does not match one you need. Then you want to create a reusable class that cooperate with the unrelated classes with incompatible interfaces. Java adapter classes provide the default implementations of listener interface, and if you inherit the adapter class, then you will not forced to provide the implementations of all the methods of a listener interface, so it save the code. Then adapter classes are found in java.awt.event and java.swing.event package. The adapter classes that with their corresponding listener interfaces are we have already seen. Then adapter classes adapter pattern work as the bridge between two incompatible interfaces, and this type of design patterns comes under the structural patterns, as these patterns combines the capability of the two independent interfaces. An adapter class can simplify the creation of event handler in the certain situation. Then an adapter class provides an empty implementations of all methods in the event listener interface. That is the class itself write definitions for methods which are present in the particular event listener interfaces. Then here the adapter classes. Windows adapter having a Windows listener, then key adapter having the key listener, then mouse adapter having the mouse listener, then mouse motion adapter having the mouse motion listener, focus adapter having the focus listener interface, and component adapter class having the component listener interface, then container adapter class having the container listener interface. Then swing adapters. Following is the commonly used adapter while listening GUI events in the swing. Focus adapter, an adapter abstract adapter class for receiving the focus event. Then key adapter and abstract adapter class for receiving key element. Then mouse adapter and abstract adapter class for receiving mouse event. Then mouse motion adapter an adapter class for receiving mouse motion event, and last one is the Windows adapter, an abstract adapt class for receiving the Windows event. Here the one of the example for mouse adapter example. Import the packages AWT and AWT event, then mouse adapter example extend to the mouse adapter, here one of the frame, then mouse adapter example constructor, f is equal to new frame and frame name is mouse adapter, then add this mouse add mouse listener into the frame by using f dot add mouse listener, this then set the size for frame, then layout and visible, here the mouse click mouse event e, graphics g is equal to f dot get graphics, and here the g dot set color blue, then fill over here the e dot get x, e dot get y and 30 and here the just call this method. This is the mouse adapter. When we click this mouse event, this is the blue color dot available in the graphics. Then the last topic from this chapter, anonymous classes. These anonymous classes of the Java are called as the anonymous because they have no name. That's why this is called as the anonymous classes, it having no name. Then anonymous class is a local class without a name. Anonymous class is defined and instantiated in the single succeedant expression using the new operator, while the local class definition is the statement in the block of Java code, and anonymous class definition is expression, which means that it can be included as the part of the larger expression such as the method call. When local class is used once, then here the when to use the anonymous classes. In general, you should consider using the anonymous class instead of the local class. The first is the class has very short body, then second is only one instance of the class is needed, then third is the class is used right after it is defined, then the name of the class does not make your code any easier to understand. Then anonymous classes in Java are more accurately known as the anonymous inner classes. The fact that they are anonymous inner classes means they are defined inside the another class. These anonymous inner classes are has unused syntax, and these anonymous classes enable you to make the classes means defines the inside another classes. Then next, the benefits of the anonymous classes. The key benefit of anonymous class is encapsulation. Second is anonymous class is and sense of the ultimate in private object oriented encapsulation. Then it is defined exactly where it is needed. It can be never used anywhere else. Then it has totally local scope. And then anonymous classes have access to all the data and methods of their containing classes, including private member, meaning for the small highly localized task, and they may require less initialization. And the drawbacks for anonymous classes. The big drawback with anonymous class is they can't have explicit constructor, and second is you can't pass them by any parameter when they are instantiated. These are the drawbacks for anonymous classes. And here our user interfaces component with AWT and Swing, this chapter is over here.